All right, well, here's a few news things, a little bit different than usual. One thing I guess everybody in San Francisco noticed, I didn't notice till I went outside, the air quality is really bad. There are fires in Oregon. So I put in my news links in case you have it, a map so you can see how bad it is. We should be wearing a mask outside. Inside it's somewhat better, because I think what happens is inside the air is still and the particles settle somewhat, but I can sure feel it in my eyes and my lungs and everything. It's not good. This was pretty interesting. There's ancient Roman glass, which pieces of it broke and fell on the ground and just lay buried in the ground for 2,000 years, and a bunch of it came out to be extremely beautiful, with like gold shining off it, and they analyzed it and found out that it has developed 100 layers of nanometer thick corrosion, which has made a perfect pattern of equal layers. So it works like a diffraction grating to make these amazing, beautiful things, which are sort of like what dragonfly wings do. And so that happened naturally over thousands of years buried in the ground, and they're trying to figure out how to do it artificially. The current system involves, I think, vacuum deposition, and they're claiming if they can do it naturally that way, they can probably do it another way, make it cheaper and make more of this stuff. So they can make new materials imitating this corroded glass, which would then be useful for a lot of optical things like lasers and stuff, and also for photonic computing, which is important for quantum computing. There are a few ways to make a quantum bit, a qubit, and one popular way is to take a particle in a state and cool it down to a millikelvin above absolute zero, which is extremely expensive and difficult. Another one involves using magnetism, but the most promising one would be to use light, because you can leave it at room temperature. And therefore you could make a chip with light floating around. And so anyway, materials that manipulate light in interesting ways will be very important as we switch to optical computing. Now, so Elon Musk, his latest idea is he's going to charge all users subscription fees on Twitter, which I imagine will finish driving away everybody that's still left on there. I left, like the whole information security community, 6 or 9 months ago, but from what I hear, it's not gotten any better over there. The only people that like it are the Nazis, basically, as far as I can tell. So this is a pretty useful instruction, and a lot of people should be doing this, using ChatGPT. You should be using it on your job. You should be using it in class and everywhere else. You should be learning how to do things, and they explain here how to tailor your prompts to get the best results out of it, which is very good. And they give you a lot of recommendations, like the ChatGPT is 2 or 3 years out of date. It only has data up to 2021, but they give you a list of others that are up to date. And they describe how to make, how to get new ideas, brainstorming, how to generate an outline, how to get a topic with sources, and so on. They explain how to write papers and examples. So I think we should all get used to using it to help us accomplish things. You have to verify information it gives you. You can't trust it very much, but it's like having a sort of junior assistant who is not very experienced and not very reliable, but will do work for you. And so this is some kind of spam. Okay, let's block this garbage. All right, so here's an article. I don't think I agree with it, but it's certainly good to see these positions. This guy claims he will never have full self-driving. And his argument did not convince me at all. His argument is that you would have to be as smart as a human. You'd need artificial general intelligence to do that. Now, artificial general intelligence is what you see in the movies. It's a robot that actually is like a human. It has intentions. It understands the world. It can move around and do things. And that doesn't seem like that's coming anytime soon. And he claims you would need all that to be self-driving, because humans are thinking about what's on the road, understanding it, and reacting. This is an interesting argument. I'm not convinced at all. I think what we already have in the Tesla shows that you can drive a car pretty well without actual intelligence, just like ChatGPT shows that you can write pages of text without understanding anything you're saying. You do not need to solve the problem of actually understanding it to write text or drive a car, I think, but we're going to find out anyway. So there's that. Now, I'm going to show you something different. Rather than following the news, I've been spending the last 2 days researching machine learning because it's getting very interesting, and I realized this is what I did literally 50 years ago. This is how I started in science. I modeled stellar interiors and other things with these models, and I fit curves, and now I'm learning the modern way to do it, so it's very interesting. So I'm just going to spend a few minutes on this. These decision trees are bloody awesome. And then the way decision trees work is they're actually completely understandable. This is a decision tree. Now, there's a famous machine learning model where this person measured some flowers. There are 3 different kinds of irises, and he measured the petal length and the petal width and something called the sepal length. And with these 3 numbers, he can sort them into categories of 3 different types of irises, the setosa, the versicolor, and the virginica. And this is the machine learning model that does that. This is what's called a decision tree, and it is something a human would write. You just have an if statement. If the petal length is less than 2.45, you go here, otherwise you go here. The colored ones mean you're done. Now you're done, it's a celosa. If it's false, then you look to see if the width is less than 1.75, and you go here and you go here, and that's it. Now you're done. Now it's not perfect. This shows you the 3 categories. There were 150 training samples. This one was perfect. All 50 supposas are in here and none of the others. But this one is not perfect. There's 49 versicolors and 5 virginicas misclassified here. And here there's 45 virginicas and 1 these things misclassified, but this is incredibly simple, and one good thing about it is it's explainable. You can answer the question, why did it make this decision, which is one of the big problems with AI models now. Things like ChatGPT. The ChatGPT does something you don't want, like tell somebody how to make a bomb or say something racist, and people say, well, make it stop doing that. And you're like, well, I don't really know how to make it stop doing that because I don't know what part of it did that. I can't turn off the part of it that did that bad thing. I can't even explain why it does anything. It's like the human brain. So this one is completely explicative, and this algorithm to make these models is incredibly simple. What you do is first you define impurity. Impurity is very simple. To define how impure something is, you take 1 minus the sum of all the probabilities of all the other options that are there. So if we look at, we go back to this, if you look at this one, it has 100% of the samples in this category and 0 in the others. So if you take 1 minus the square of the probability, you get 0. That is 0 impurity. This is perfect purity. This one here has got 49 out of 54 in the main category, so that's a little bit less than 1, and 5 out of 54 in another category. So when you subtract those, it's going to come down from 1 to 0.8 or 0.7 purity. This is how you measure purity. So now you define what you want to do is you want to make as much purity as possible, where it separates it into groups like this, where you've really found the answer. And so the algorithm is here. I was training down here, and I still got 3 minutes, so I just wanted to show you this because I think this is bloody awesome. Okay, here's what you do. You split the training tree. You choose a feature, and then you split it on a threshold t, makes it less than or equal to t, and you choose k and t to find the value that produced the purest subsets. You calculate the purity of the next node down, and you adjust it to where it's as pure as it can be. And then you do it again and again and again, and that's it. That's all you, this is incredibly simple, incredibly fast, and it is amazingly effective. So if you want it in mathematics, that's what it looks like. But anyway, the point is, it's extremely fast. Making a decision on a new sample scales as the log of the number of samples because you just have to make one path down the tree. And training it is only n log n. So it's very fast. And so if you look at the results, it gives you a fit. If you have no restrictions and you let it go until it's done, it makes a crazy model like this. But if you tell it to not make a leaf that has less than 5 samples in it, then it does a really good job of fitting this thing where you have a curve of samples here and a curve of samples there, and you're trying to tell them apart. And one thing that's crazy about it is if you try to fit a curve with it, it doesn't fit a curve, it fits a bunch of straight lines because it's a bunch of if statements. So if it's in here, it gives it that value. If it's in here, it gives it that value. So that might seem like a really bad idea, but if you just let it go further, it gets very good. In fact, it will overfit to where it fits not only the signal, but the noise. And you have to smooth it out to one like this to get the best fit. But the point is, these things are very efficient. And what's even better, one problem with these things is if you change anything, it will make a flaw. It's random. It chooses a random parameter to split on and another one. So when you train it one time, you'll get this model where everything with the length less than something is over here. The next time you train it, it ignores the length entirely and just does it on the other parameter because that will also work. And there's nothing that makes this model better than that model. So it gives you different results when you just retrain it on the same data. So the most powerful AI model available now is based on a forest of these decision trees. You make a bunch of decision trees and average them together, and you have a very powerful model, and it's very fast to learn. So anyway, I'm very interested in that, and that's why I thought I'd spend 5 minutes talking about it. That's what I've been spending all day thinking about. This is brilliant, and it is so simple, and it is so fast. And it creates models that not only work, but you can explain how they work and adjust how they work, which is completely different than the neural net type models like ChatGPT, where you don't really understand how it works or what to do about it. It's like a real brain.
I have heard that it's really hard for AI to unlearn something.
Yes, there's essentially no way to unlearn anything in a neural net model. That's a problem. And but this kind of model, you totally understand how it works. It's just a series of if-then statements like a human would write. So if you don't like what he's doing, you could go in here and change those statements. That's why it's understandable, as opposed to the neural net. So it's a very interesting kind of model to know about, and that's what I wanted to